Origin's Gauge Study offers a suite of tools designed to measure error in measurement systems. Before any complex measurement system analyses are done, quality compliance standards mandate that an initial Type I gauge study should be conducted to document the device capability. Or, in other words, to measure the accuracy and precision of the measurement device. Under a Type I gauge study, a single operator will use a device to take repeated measurements, usually 50 or more, of a single part with a known reference standard. Our example dataset includes 50 observations measuring a pipe's diameter. The engineering team purchased a new micrometer, and they are interested in knowing just how accurate and precise the new micrometer's measurements are. A single operator tested the new micrometer by taking 50 repeated measurements of a single pipe's diameter within a controlled environment. The engineering team knows that the true diameter of the pipe is 25 millimeters. The engineering team is willing to accept measurement variation within plus or minus 0.5 millimeters. Anything more is too variable. Let's open the Gauge Study app. Measurement data are in column B. Reference value is the true diameter of the pipe. This is 25 millimeters. Measurement tolerance is the difference between the acceptable measurement limits. Difference between the upper specification limit of 25.25 millimeters and lower specification limit of 24.75 millimeters is 0.5 millimeters. Percent of tolerance is one of the values used in the formula for calculating CG. The default is 20%. Study variation is the number of standard deviations multiplied by the observed standard deviation. The default is 6. This is because, under the normal distribution, 99.7% of the measured data will fall within plus or minus 3 standard deviations. Resolution is the finest unit of measurement that the gauge is capable of detecting. The new micrometer can detect 0.01 millimeters. We'll enter this under resolution. The tolerance bands of the run chart are calculated using the reference value plus half of the percent tolerance, which is 0.20 divided by 2, multiplied by a tolerance of 0.5. For the upper band, this is 25 plus 0.1 times 0.5, which equals 25.05. For the lower band, this is 25 minus 0.1 times 0.5, which equals 24.95. The run chart shows that 6 values fall beyond the upper band, suggesting that there is too much variation in the measurement values. Let's take a look at the statistical test to see if the variation documented in the run chart is statistically significant. There are 3 tables. The basic statistics table shows that the reference is 25. The mean of the 50 data points is 25.0088. The standard deviation of the 50 data points is 0.0243. Next is 6 times the standard deviation. We specified a study variation of 6 in the input window, and this displays 6 times SD. The tolerance specified in the input window is 0.5. The resolution specified in the input window is 0.01 millimeters. Industry standards suggest that resolution as percent of tolerance should be less than 5% or less than 10%. The good label shows that this value falls within the recommended industry standards. The second table tests for bias. The null hypothesis is that bias is 0. Bias is measured as the difference between the first 2 rows in Table 1, mean and reference. We can conduct a statistical test to determine the device capability. The null hypothesis is that bias equals 0, and the alternative is that bias is not equal to 0. With a t-stat of 2.56 and a p-value of 0.01, we reject the null hypothesis that the bias is 0. The third table provides summary values for common capability measures. CG and CGK are used to measure device capability in a Type I gauge study. CG measures the device's repeatability. CGK expands the formula for CG to measure both repeatability and bias in the measurement device. Results indicate that there's too much variation in the new measuring device, and that it should not be used to measure pipe diameter. If you go back to the Gauge Study main screen and click on the question mark at the top right, you will be taken to the home page for Origin's Gauge Study app. The algorithms used to generate the table summary measures are provided under this link.